So you too, right?
Yeah.
Um, okay, MSP
Inspire.
Beyond Coding.
So we are ready. Let's just wait for 1 or 2 minutes and then we start.
Yeah, it's sort of
Yeah, I'm feedback right now.
yeah.
On the line.
Can you imagine? Um, I think we can start. Done.
Yes. Yeah. So I everyone here is from OA University. So hi guys. I'm Ekansh and I am from India. And Okay, so hello people from the world. Yeah. So actually, so let's. I think Dami has given a good introduction of me, and I just want to say that I am so glad to be here. And yes, so we are going to talk about hacking web literacy, and this is a talk that I gave in London 2019 at Mozilla Festival, and it's actually pretty useful and we should know about it. So there I am. And so most of the time when we hear hacking, we just assume that we are going to penetrate some firewalls, we are going to take some data, we are going to use it for something else, and all those things that are shown in popular TV shows, like you just write 2 or 3 lines of codes and everything is done, but it's not. So first of all, we are not going to try and enter someone's firewall or someone else's computer. We are just trying to, you know, uh, get people aware about what hacking web literacy is, what web literacy is, and how companies like Netflix and Amazon Prime and Spotify gives you recommendations uh, based on your viewing preferences, likings, and ratings, and all. And secondly, how do they take this information? So I would like to say that obviously they take this information by the help of cookies, and we are not going to discuss more on cookies, but uh, something what cookies do max to max. So cookies are some what do we call it, some extensions, some HTTP requests which is there in the browser, which takes up user data. It takes up the metadata, it tracks down users, it tracks down their activity, it tracks down what they do and what they don't, what they see and what they like. And if you go to any website right now, you can see that there is this accept cookie policy, and they are trying to make you aware that they are going to take your data. So that's the use of cookies. On to the Netflix part. So everyone in the world is watching Netflix right now because coronavirus and lockdown. So we have nothing to do better than to watch Netflix or go to Amazon Prime Video and just watch some movies there, or some binge watching or something like that. So how does Netflix know what you like or don't, and how does they recommend that okay, this movie is something that you might like, and this is the show that you might not like, and this is some kind of series that you would love to binge watch? How do they know? So that's where, you know, the collection of user data, the ratings, the algorithms, machine learning, and all this comes in. I am an enthusiast machine learner, and I love to code on Python. And so let's start with the machine learning algorithms that are used here. So what did I say? I forgot. So sorry. Um, I was talking about machine learning. So Netflix uses this algorithm which is called collaborative algorithm for machine learning, which they use for recommendation systems, and a lot of companies use recommendation systems, and collaborative learning and algorithms are used to give uh, recommendation systems here. So what we are going to talk about in recommendation systems, we are going to talk about regression methods, we are going to talk about matrix factorization, we are going to handle a case study here. So that way you are going to know what we are dealing with and what Netflix goes through day to day. So Netflix, just some information that I want to put out here is that Netflix doesn't use a full-fledged server to go through your queries. They use something known as Kubernetes. And that's all that I want to say, because that's a fun fact of Netflix that I know. So I just share everywhere I go. So let's start with the recommendation system. And Dami, should I share my screen right now?
Yeah, you can share your screen.
Yes. So let's start with it. Okay.
Yeah, you can share your screen.
So for the sake of understanding, let's keep this a little bit short, a little bit crisp, and let's start. So let's assume there are only 4 people in the Netflix universe, and we will call them Anna, Betty, Carlos, and Dana, and we will abbreviate them with A, B, C, and D. And then we have these 5 movies in the Netflix universe. They are based on something or the else, but some are related and some are not. So we will go through the slides and we will know what we are talking about. So these are 5 movies. This is Mall Cop, Twister, Jaws, Observe and Report, and Sharknado. So you might see a similarity in some of the movies, and you might feel that some of the movies are totally different. But for the sake of understanding, we are only keeping 5 movies here and 4 people. So A, B, C, and D are the only 4 people that are currently in the Netflix universe. So let's assume that Anna gives the movie 5, Sharknado, a rating of 4 stars, and Betty gives 1 star for movie 2, Carlos gives 3 star for movie 3, and what's the name of the 4th person? Dana gives like 5 stars for the movie 4. So that's how they have given you movies. Now let's talk about how humans behave. So there are 3 pictures here, and we can safely assume that the first picture in this slide, we can surely say that this is not the case in any universe. Not every person is the same, neither is any movie the same, and every person might have a different perspective to different movie, and they might just go with the flow. So I can safely assume that the first picture does not represent how a typical Netflix user database might look like. And let's go to the third picture. So that's also not how humans behave. So this is quite random, because some people have the same or similar tastes. Some people like the same movies, some people like 2 genres at once, some people do not like a movie at all, and people have varying taste but are somewhat very similar with each other. So we can see some similarities, some bond between the people in the picture too. So let's continue with the matrix, the graph, whatever we call it. It's actually yeah, that's actually a matrix. So let's continue with the matrix too, because in the next slide, when we show dependencies, we can show that some people are the same, some movies are same, some movies are an average of 2 movies, some genres are average of 2 movies. So let's continue. So let's find out some dependent rows and columns. If I will give you like a minute to find out some dependencies, and then we will continue. So like I said, that people are not very different. They are very similar. Not, but yes, from a machine standpoint, machine viewpoint, when we are trying to make a machine learn something, we always try to see what are the similarities between people which two people can we say are same and consider it one, which two movies can be considered as one because their ratings are the same, and how do we consider the dependencies of movies on users. So let's start with the dependencies. So we can see that user A Anna and user C Carlos have the same ratings for every movie, M1, M2, M3, M4, M5. We can see that they give the same ratings for every movie. So because Netflix is not a human, neither a recommendation system is. So they safely assume that Anna and Carlos are one person. So whatever Anna will give the rating to, the Carlos guy will give the same rating to any of the movies. So whatever they recommend Anna, they will recommend the same movie to Carlos. So let's continue with the next dependency. The next dependency, as you can see, is like every person gives some rating for M1 movie and M4, but as you can see, similar ratings are given for M1 and M4. So for Netflix standpoint and Netflix perspective, in the previous slide, as A and C were similar, in this slide, movie 1 and movie 4 are similar. They might not be the same movie, but Netflix consider them as one. So the next dependency is, yeah. So as I was saying, that M1 and M4 are very similar. So Mall Cop and Observe and Report, if you haven't watched any of those movies, you can go and watch, and you can safely see that Mall Cop is about a cop in a mall, and Observe and Report is actually the same movie, where the same genre, the same storyline, where there is a mall and there is a cop, and that cop is in the mall guarding something. So that's why Netflix is assuming that M1 movie and M4 movie are the same. So the next dependency are between these three people. So what we can say is that Betty and Carlos here have given 1 and 3 rating to movie 1. If we are just saying about M1, Betty has given a rating of 1 to M1, and a rating of 3 is given by Carlos to M1. And when we go to Dana, it's 4. So what we can see is that the ratings are an addition of Betty and Carlos. So what we can see is like if we can assume that Betty likes action movies and Carlos likes comedy movies. So Dana is someone who likes both comedy and action movies. Therefore, there is a union of their ratings. So a person who likes both comedy and action movie will definitely like a comedy movie and definitely like an action movie. So that's why there is a union of these two people. So Netflix sees that whatever movie that we recommend to Betty and whatever movie that we recommend to Carlos, both of these recommendations can be applied to Dana as well, and in union. So if we go and recommend Betty like 5 movies and 5 different movies are given to Carlos, Dana will probably get a list of 10 movies for their recommendation. So the next dependency is actually quite huge and a quite big dependency. So if you can see, the movie 5 is actually an average of the ratings of movie 2 and movie 3. So how come? So like movie 2 was Twister and movie 3 was Jaws. So movie 5 was Sharknado. So Sharknado is a movie where there are huge lot of sharks, numerous sharks, but also in a hurricane, tsunami type of thing. So there's a twister of sharks. So that's why movie 5 has been considered an average of movie 2 and movie 3. So it's an intersection of these two movies. Sorry, so let's continue. So Sharknado was an intersection of these two movies, movie 2 and movie 3. We can see the ratings matrix as well, and in the matrix rating of movie 2 and movie 3, we can see that 3 plus 5 is 8, and movie 5 has been given a rating of 4. So the average is 8 divided by 2, 4. So let's move on. So how do Netflix guess ratings? So if this is the case in the slide where everyone has given equal ratings to every movie, then the movie 4 will be given the same rating, because Netflix assumes that every movie is equal and every person is equal, but this is not the case in real life. There are like thousands and thousands and tens of thousands of movies, and there are like millions and billions of people on Netflix, and no two people are same. They are similar, but they are not the same. Yeah, two people might like the same movie, and for Netflix it may assume that these two people are same, but in real life they are rarely not. They are rarely the same people. So let's continue. So the column for movie 5 is empty for Carlos. So how can we assume the ratings or guess the ratings for movie 5 if we know every rating of every person here? So there are two ways to do that. One is because we have already considered in our previous slides that Anna and Carlos are same. So the ratings of Anna and Carlos would be same. Therefore, the ratings given by Anna for movie 5 is 1. So Carlos will give a rating of 1 to movie 5 as well. The other way which we can think of the same ratings or dependency on ratings would be if we considered the average thing. So Carlos has given a rating of 1 to movie 2 and a 1 to movie 3. Therefore, he will always give an average of ratings on movie 5. So that will be 1 as well. So there are a lot of ways on how we can guess ratings. So the next slide is how do we figure out of all these dependencies? So the answer is matrix factorization. So I'm assuming for the people who have learned maths in their high school or does know anything about machine learning, statistics, or something or the else, they might know about matrix factorization and what matrix is, what factorization is, and we are combining just the two. So how matrix factorization works, why is it useful, and why is companies like Netflix and Amazon using it? So the answer is in the next slides. Sorry. Yeah. So we are assuming that now we are assuming that the movies have various features and are not dependent on only one feature or genre. They might be classified on comedy and action, drama. There might be a big boat like Titanic. That movie might have a sad dog. A movie might have Meryl Streep in it, or a sexy Canadian actor like Ryan Gosling, or the other Ryan. I don't remember his name. Let's leave it. Or the movie might be scary like the Insidious series. So movie is not only based on one feature. Netflix classify movies on various features, but for the sake of understanding, we are only going to deal with two features, and a movie might be based on comedy, a movie might be based on action. So yeah, so we are taking only two features into account. One is comedy and one is action, and we are introducing the law of dot product. For the people who have learned vectors, they might be familiar with dot product, but those who are not, we are going to go through with it. So yeah, so Anna likes comedy and dislikes action, and she has and a mall cop has a rating of 3 on comedy and 1 on action. So the dot product comes here like we consider a tick mark as 1 and a cross as 0. So a dot product will be 3 into 1 plus 1 into 0. So it will be 3 into 1 plus 1 into 0, which will be 3. So every person has given their preferences on the genres. So if Anna likes comedy and Anna hates action, it will be given a 1 on comedy and a 0 on action. Likewise, a movie might be rated on how they are with the features of their genres. Movie might have a rating of 3 on comedy and 1 on action. And by that, we can find out what are the ratings and what we can assume the ratings of different people as well. So, uh, sorry guys, can you wait for a second? Uh, Very sorry.
Okay, no problem. No problem.
Hi, I am back.
Okay, awesome.
Yeah, so we were on dot product and we were guessing ratings. So let's assume that Carlos likes comedy and Carlos hates action, and we are guessing the ratings for movie 4. Then Carlos, the ratings for comedy for movie 4 is 3 and for action it is 1, and likewise Carlos will give 3 into 1 plus 1 into 0, which is a rating of 3 stars for movie 4. So see how much space we actually conserve by doing matrix factorization. We have not yet explained matrix factorization here, but we can see that we don't have to make that whole big matrix. We can just use these two matrices to find out that one big matrix. So yeah, so what is factorization? If we say how can we come up with uh, two numbers that will equate to 24? So a person might say 6 into 4, and a second person might say 8 into 3, and they both will be correct. So we are going to find the this and the that which is going to multiply into making this huge matrix. So the features that Anna and Carlos and every other person have given here, their own preferences for these features are given. So if we can see, they have made two columns for features, and in the movie thing there is another matrix for the movie part where they have been giving ratings on what genre they are of. Like we considered Mall Cop has a rating of 3 on comedy and 1 on action. So that's how we can go and find out the ratings for every other person given to every other movie. So let's find out how. Betty has given a rating of 4 to movie 3. Let's find out how we use these two matrices to find out the ratings that Betty has given to movie 3. So Betty likes action and hates comedy, and we are going to talk about movie 3. So movie 3 has a 4 rating on action and 1 rating on comedy. So 1 into 4 plus 1 into 0, that's equal to 4, and that's how we come up with this huge matrix. We can literally point to any ratings with the use of these two matrices. You might feel, why are we extending our work? But we are actually not extending our work, but conserving space here. So in the next slide, you may see how. So yeah, so like assume there are like 2000 users and 1000 movies. So the whole big matrix will consist of like 2 million entries, because 2000 into 1000 is 2 million entries. But if we factorize that into two smaller matrix, so we can consider 100 movies and 1000 movies and 100 features, and it will go into multiplication, and it will spit out a value of 100k entries. And in the second matrix, we will have 2000 users and 100 entries, and we multiply 2000 with 100, it's 200,000 entries. So if we can see, there is this 2 million entries, and there is like combined entries of 300,000. So we can see that there is a huge deal of conservation of space here, and storage is a big thing when it comes to large organizations. You might feel like this is very small, or you can store this on your PC or laptop, but there are not only 2000 users, there are like millions and millions of users, and there are like more than a million of movies, and Netflix has to save that and search it and scrape it, and they have to recommend all these movies to all these different users. So howsoever you may save space, it's always is beneficial for Netflix only. It's faster for them to search, it's faster for them to store, it's faster for everything. So if you save space, they save time, energy, and time is money. So obviously, so this is a matrix, but people don't always go with matrices. They feel more connected with graphs. So if we go here, 4 people have given ratings to 5 movies. So 4 into 5 is 20. Here, if we introduce 2 features in the movie and in users database, then 4 people into 2 is 8, and 2 into 5 is 10. So that's 18. See how we save space. There are like 20 ratings here, and we have to give only 18 attributes here. You might not see a very huge difference here, but when we scale up, like in the previous slide, we see that here we have 300,000 entries only, as compared to 2 million entries. That's how when we scale up, we actually save a lot of space. So how do we find the right factorization, and how do not only we, but how does Netflix, the machine, the recommendations system find out the right factorization? So first, what the recommendation system does is it spits out general garbage data and find out the closest one. So as we can see, for features 1 and 2, Anna has this garbage value for Anna is 0.2 and 0.5, and for garbage value of movie 1 is 1.2 and 2.4. If we multiply those to get the rating for Anna for movie 1, it's 0.2 into 1.2 and 0.5 into 2.4, which comes out to be 1.44. And if we go see our actual ratings, then we see that 1.44 is not very close to 3. So how do we go and close this gap between 3 and 1.44? So there is something known as error function, and it's used in regression models. So error function is the square of the root mean square of the square of the difference of errors. Why the square of the difference of error, you might ask? Because here we have 1.44 instead of 3. But if we see in movie 2, it's 1.37, and in movie 2 in the original ratings, it's 1. If we directly subtract it, 3 minus 1.44 might come out to be positive, but 1.1 minus 1.37 will always be negative, and we can't have an error of negative because it will actually destroy how we are going to converge on to the errors, how we are going to minimize on the error, because there is a positive error and there is this negative error, and it's very confusing for 2 different signs in an error. So that's why we just square it up, because square of a negative number is also a positive number. And when we plot a graph, it's a quadratic equations graph, and we just want to go to the base of that graph, just to get to the least error we have. So the error function is 3 minus 1.44 and it's square. So we have to minimize this error. So how do we minimize this error? So there is this approach that we use, which is known as gradient descent. So yeah, so a gradient descent is let's use paint here because it will be more useful. So paint. Yeah, so this is a graph. So this is the positive x-axis and this is the positive y-axis here, and this is the graph of a normal regression model. So this is a quadratic equations graph. Y is equal to x square, ax square plus bx plus c, but we are going to just say x square. Okay, and 3 minus 1.44 is somewhere in the neighborhood of 1.5, and the square of it will be in the neighborhood of 2.25. So it will be somewhere here. So how do we come to a point where there is the least error? Here the error is 0. How do we do that? So when we do linear regression, we try to minimize the slope of the equation. So first we do this, then we do this, then it comes here like this. We never approach to a point where the error is totally 0. It might be somewhere in the neighborhood of 0.1, 0.01, but it will never be 0. So that's how we minimize errors. So we always want to just go and minimize these errors somehow. So yeah. So we have the error function here. We have 1.44 here. So what do? We might increase the value of 1.2 here, or decrease the value of 1.2 and increase the value of 2.4 here. We just have to play with the numbers. That's how machine learning does their work. So there is a great joke about machine learning. So this joke goes like this. We know that 3 into 4 is 12, but how does machine learning understand it? So a machine understands it like when we say 3 into 4 is equal to 12, it says 3 into 4 is 2. Then it says 3 into 4 is 4. Then we say no, you are incorrect. Then it goes to like 3 into 4 is 18, and we say no, it's 12. And it says that 3 into 4 is 8, and we said no, it's 12. And then it goes like 3 into 4 is 14, and then also we say no, it's 12. So finally, after some iterations, some looping through backwards and forwards, it comes to like 3 into 4. Okay, fine, 3 into 4 is 12. So that's how we are teaching machine what 3 into 4 is. So it is like teaching something to a baby. They might have to iterate numerous times. They might have to take longer times, but when it comes to a conclusion, it generates pretty accurate solutions. And that's why we can guess the ratings of every person dependent on their previous ratings, because we have minimized an error to where it is actually acceptable. So here we, if we remember previously, then here we increase the value of f2 from 2.4 to 3 and f1 to 1.2, from 1.2 to 1, and it's just random for machine to do that. But when we have the exact values to where it has to go, then it's called machine learning. So in machine learning, we have an input and we have this output, and the machine has to find out how does that input is actually related to the output. So what's the part to take? Is it just multiplication or it's some other logic? That's how machine learning works. That's how any of the artificial intelligence model works. That's how basic human brains work. So machine learning is nothing, but we are trying to teach a machine how to think and develop like a human brain. So and also we are trying not to go it not to uh, make a machine rogue and become something like Terminator, who is going to come back from the future and kill Sarah Connor. No, we are not trying to do that. Uh, but obviously there is a possibility and we are trying to control it. But we are not going to talk about it because there is already a pandemic going on here and we are only trying to guess the movie ratings. So how do we use this? So the machines spat out its data with the given values, and we have to find out the values of like M2 for B and M3 for D. So how do we do that? It's easy, just the dot product, because machine has done all of its work and it has minimized all the errors. So we have come close to a perfect solution now. So like if we try to find out the value of rating for M3 for Dana, we will say 1 into 1 and 1 into 4, and we'll just add it and it will go 5. And that's how Netflix gets ratings for everyone. Obviously, you don't go to Netflix and watch movies and then just go through the ratings. You don't go to every YouTube video and like or dislike it. You just leave it there. But how does Netflix comes up with it? How does Netflix find out that if you have liked the movie or not, because you haven't given your feedback to it? So there's the part of cookies. There's where cookie comes in. So what cookies do is they try to extract data from what a user has done. So if we leave a movie in the first 10 minutes, then it's pretty accurate that you don't like the movie. But if you have watched the movie till the end, Netflix assumes that, okay, sure, he might like this movie. If he likes the movie which is similar to this movie, then obviously he likes or they like the features of this movie, the genre of this movie, and they try to correlate things like we have gone through with the features here. Okay, if a movie has both comedy and action, so if I like this movie which has comedy and if I like this movie action, Netflix will probably recommend me a movie which has both comedy and action, and it will try to see if I complete the movie and if I try to find a movie which is having both comedy and action. That's how Netflix gets data. It just uses cookie in their browser to get this data and compile it and make this huge database so that you are actually right time and some good enough movie is being recommended to you, some good enough TV show is being recommended for you to binge watch in this pandemic. And I think that's all that I would like to say in this recommendation systems part. And obviously recommendation systems do not work solely on linear regression. When you have a database of more than like a billion people and a million movies, linear regression is just a way to just sort out through very less amount of data. We have to go up in size, we have to scale it up, and that's when we have to introduce new algorithms. That's why we do matrix factorization to get this data down in size, save storage, save space, such that we don't have to work on this whole whole chunk of data. We have to work on a part of its data. That's why, okay, data is something that's actually very, very, very precious right now. Everyone wants to collect their data. So how do they compile their data? They want something like matrix factorization or something or the other to compress this data. And every algo we use further, we use it on a database which is very compressed. And every company, every organization tries to track down what you do, how, what you like, what are your preferences, just that they want to give you a better experience when you go back to their site. And Mozilla is one of these organizations which will help you in finding out which cookies are good and which cookies are bad. They are trying to revolutionize this internet health movement, because internet is full of this scams now. But we want to go and enjoy, we want to make it as a part-time thing, and we don't have to just worry about our data anymore. So that's why we learn about web literacy. That's a generic topic about, that's why I talked about on web literacy. And that's why we should just hack our way into web literacy, so that we are we are well protected, and we are um, enlightened on how people do stuff. So that was it on my talk. Tami, you can take over. Thank you so much.
Whoa, whoa, it's a lot. It's a lot. Like, I really, really have to go back and rewatch this program like 4 times in order to digest everything. Can you hear me, Akansh? Okay, you've missed yourself.
Yes, I can hear you,
Oh,
Tami.
awesome. Like the program, your session was awesome. We learned a lot, and I've always figured out how Netflix or Amazon does their recommendation. I watch this kind of movies, and then they show me this kind of movies, and I've always come up with series of theories in my head. Like, probably they just look at what people are liking, and they think if someone likes this movie, and I also like this movie, if someone else like another movie, then they will definitely suggest that movie. There have just been a lot of theories in my head on how they figure out their recommendation systems to movies I love. But you've broken this down, and I really, really understand a lot now into recommendation systems. Though there are a lot of maths into it, if I'm to build probably my own e-commerce and I want to add code my own recommendation system, there are a lot of maths. I probably need to go back to my algebra or something, but then it's 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 really, really awesome. And then when I was introducing Akansha, I forgot to, like, I didn't give you his full bio. It's not like a bio, but then I said he's an MSP and GitHub campus advisor. But then he's also a Google coding mentor at Cyclesverse. He's a facilitator at Mozilla. He's also a facilitator at PyCon Italy and head of corporate and external affairs at IOSD. So it's very, very awesome to listen to you, Ekansh, and I definitely must go back and re-listen to this video. So our next speaker for today would be Bushra Ahmed. Bushra Ahmed is also an MSP at the Obafemi University, and she'll be talking to us about machine learning with Azure. Bushra, are you on the call?
Yes, I'm on the call.
Yeah, awesome. So Busha will be like just informing us about how to handle machine learning on Azure. Ekash spoke a little about machine learning, but then it sounded too mathematics and everything. But then Busha would probably make it easier for us by telling us how we can leverage Microsoft Azure and their machine learning studio and everything to just easily have access to machine learning and do anything related to machine learning. So over to you, Bujo.
Okay, thank you, Dami.
Yeah.
And thanks, Akash, for the session. I really enjoyed this session. So I'll be taking this session on Azure machine learning, how to use Azure Machine Learning Studio, basically. So I'll share my screen for with you guys. So okay, yeah. So basically, what's Azure Machine Learning Studio is just a graphical web platform that is used for performing machine learning operation using visual flows. So this on my screen is more like a white paper from Microsoft on Azure Machine Learning Studio. So basically, what you can use Azure Machine Learning Studio to perform lots of tasks without even writing any code, and it's even possible you can perform tasks like anomaly detection, a recommender system, more like what Akash talked about, a regression model, text analytics, and they even have computer vision. So using OpenCV library, and you can like one good thing about Azure Machine Learning Studio is it's possible to import data from different sources. So more like you have a quick project you have to work on, and you really need something like easy to go. Like you don't really need to sit down and start writing code or start thinking about the whole logic. But you as a more like as an average person with machine learning or knowledge, you're aware of the whole flow, what you really need to get your final output. So, but you really do not want to stress yourself to start writing the whole code. So, if you're that person, Azure Machine Learning Studio is for you. So, so this session will be more of our interactive session. So, I'll be working with a popular data set, Titanic data set. So, for this session, I'll just be working on data cleaning. It's 17 hours. Data or a bit of data manipulation. So it just kind of straightforward, not complex stuff. But at least for us to have a walkthrough around what Azure Machine Learning Studio is and how we can leverage on it to perform machine learning or to solve machine learning related problem. So go to my okay. Okay, so I'll import the Titanic. So before then, so I got the data set from the official cargo competition or website. So you can access it via cargo.com/say/Titanic source data. Okay. Yes. So the data is uploading right now. Okay. So I have the data on my so this particular studio is a free workspace. So you don't need Azure or credit for that. At least when you're still working like on a mini project like this. So I'll start my experiment. So the first thing, like when you're working for any project, you start an experiment. So basically, that's what I'll be doing. So they have lots of pre-trained experiments on different uh, types of like machine learning problems. So you can actually like sit down and explore those experiments just to like have more feel of the machine learning studio. But I'll create a blank one. Okay. So now I have my experiment. So the first thing is to, so for every machine learning project, the first thing is to have a training data in which the model will learn from, and also later on probably be able to predict on the text data. But now the first thing is to have a training data so that the model has something to, series of patterns to learn from. So that's the first thing I'll be doing. I'll be loading my saved data, which is the train.csv. So the next thing is for me to check the data. And one like awesome thing about this machine learning studio, you get to visualize your data without even having to write code or like going through lots of series of like processes. So so I can explore my data, try and compare. So for this now, for this problem, we are trying to predict like the people that actually that will survive in the Titanic ship. So for this program, we're using classes like the P class. I guess the P class is more like, okay. So this is the project overview. The okay. Okay, nice. So they kind of explained what all the columns, what they are. So for survivor, which is what we're trying to predict whether one will survive or not, and the P class is the ticket class. So that's the ticket class. The sex is the gender, the age, the SIBSP, which is like probably the person has siblings or spouse aboard the Titanic, patch, ticket, fare, cabin, and back. So these are the descriptions. So go back to the experiment. Get more insight. You should be able to compare different columns with this the label, which is survived column. So we're trying to check whether probably people like more female actually survived or not, or probably people between the age of 20 to 30 survived the. Okay, so okay, now for for sex now, we can see we have more female survivors than male, which means more female actually survived the whole Titanic boats capsized than females. I mean, there are males. So the P class. So that means people with ticket 3, which is yeah, people with third class tickets actually survived more than people with first class ticket. So and also we can also check for more like a quick description about a particular feature. So more okay for name now we're able to see that name as string type and it has 0 missing values and 891 unique values. So most likely for this kind of problem, we don't need the name because it's not an NLP task, or we are not actually dealing with strings. And from here we can see that we have 891 rows all together. So for sex, we have 2 different unique values, and that's telling us that, oh, this is more like a categorical data, because we're able to know that, with two unique values, that means we have just male and female. So for age, because age is more of a numeric data, so we're able to compute the mean, the median, the minimum age, the maximum age, and from here we can actually infer that, oh, for this kind of minimum age, we definitely have outliers, or we probably have outliers, because how can one be 0.42? Like, it doesn't make sense for age. So, and we have standard deviation, number of unique values, the number of missing values, so which we should take into consideration when training our model. And we can see the distribution. So for ticket, so we have ticket as string feature and 0 missing values with 681 unique values. That means some people have like the same ticket ID. So embark, which has 3 unique values with S, C, and Q, with 2 missing values. So from the O features, we can see that only embarked and age as missing values, which we need to look into while preparing our data for training. So for the rest, we don't really need the passenger's ID for the training, because okay, it's just an ID. We can only use it to hold the ID, probably when we're trying to generate a submission data set or something. So also for the name, we don't need it for the training. And okay, so for cabin, the reason why I felt okay we might have to remove cabin from the training data is because it has lots of missing values, and trying to impute those missing values might lead to biasness or might affect the data, because out of 891 rules, we have 687 missing values. So that means trying to uh, impute those missing values is a bit hard because of biasness. Because for any machine learning model, we have to be careful of being the model being biased because of a mistake we made during the training or the data preprocessing. So from here, I'll now select the needed columns for the training. So there's an item I can use there to do that. Select, so select columns in data sets. So, and I think you can see this. So this is where I launch the column selector and pick all the necessary columns I need for the training. So I picking survivor, age, pick class. Okay, let me go back to the Okay. Okay, I'm using sex, the fair, embarked, SIBSP, Pash. Yeah, I think that's okay for this session. So there should be a drag selector, but I don't know why I'm not getting that here. I'll just have to type sex but I think nice. So to check if I actually picked those stuff correctly, I can run this selected cell. Okay. Yeah. So there's an issue here which says column survivor not found. That means I probably didn't spell it right. Okay, survived, not survivor. So that's a way to cross check whether the columns I actually picked are right. Oh, nice. So I can run again to yeah. So I can now visualize that. Nice. So I have all the selected columns now. I have 8 columns. So the next step is to check for missing values, which I did earlier. So now time to clean those missing values. So I have one. Okay. So I have 177 missing values from H, and I also have 2 from embarked. So there's an item to clean missing values. Yes. So that's under transformation manipulation, because that's still part of data manipulation. It's still like data thing. So it has settings. So I can actually set it to clean missing values between uh, from like minimum 0 to maximum of 1, or I can say, oh, once I have missing values above 2, you should clean them, or once I have missing values below 100, you can clean those ones. So and there's cleaning mode. So it depends on what I really want to clean with, like the method. Probably I want to replace those missing values with the mean, replace with the median, replace with mode, or remove the entire row or the entire column, or using probabilistic PCA. So for this, I'll be removing the entire row, but like in a real project, it's better to dive deeper into those columns and try to like pick the best method. So more like, for age, I might feel from my analysis and my research, I might feel it's better for me to clean with main, median, or mode. Yeah, hello. Hello.
Yeah, we can hear you. Are
Okay,
you?
nice.
Yeah.
I had okay, so it's one might feel it's better to clean with mode, main, or any other form of transformation on the data. So I'll be removing the entire row. Okay. So now I have done that. So what this we do is just to check all columns for missing value and try to clean. So the next step is to encode categorical data. Because I have categorical data like embarked, sex, so I need to encode them because machine doesn't read string, it reads numerical values. So I'll be using edit metadata for that. Okay. So from here I can pick or I can pick the columns I want to encode. So I'll be encoding sex and bag. Okay. Okay. So so for me to convert them into uh, like it's more like using a label encoder. So for me to encode them into zero and ones, I need convert to indicator value experiment item to do that. So and I need to overwrite the categorical column so that I'll be able to so I won't have duplicates because I'm encoding those categorical columns. So definitely it will create a new column with zero and ones and the previous column will still be there. So I need to override that column. So I still need to so from here I can run the experiment to see how my data is. Okay. So there's an error like here. Oh, nice. So that's because I picked integer here, and the format is actually not an integer. Uh, so from here I checked the other time to see the data format, which is so for sex it's a string feature. So that's why I ran into that error. So I have to run that again. Okay, so I can check the data now. Okay, so I can see it has created new columns. So for sex, I have sex female and sex male. I have embarked C, embarked Q, embarked S. So that's because for embarked, I have 3 different unique values. And for sex, I have 2. And it's kind of encode them into numerical values so that I'll be able to pass it into the algorithm for data modeling. So from the next step is, okay, since more like I have my data ready for modeling, the next step is for me to split the data into 2. So one will be used for training and the other will be used for evaluation, for test. So I can just pick split data. So split data from here. And I'll set the ratio. So for me, I prefer 0.7. And this is more like different options for me to pick. And even if I want it to be stratified, please split, and the random seed too. I don't want that, so I'll just pick the number, the fraction row. Okay. So now I have 2 outputs pointers. So one is for the train set and the other is for test sets. So for the train, I need train model. So I need train model. So this is where I'm going to indicate my label column that I'm trying to predict, because from the beginning I've been loading like all the columns. I didn't indicate that this is my target label. This is what I'm trying to predict on. So now I'll pick that, which is survived. Yes. So I'm trying to predict on survived. And I'll connect. So for that, I still need to add the type of algorithm I'll be using. So this is a classification problem because I'm trying to predict whether this person will survive or not. So classification. Okay, so these are the available classification algorithms on Azure Machine Learning Studio. So for this part, for this tutorial, I'll be using a decision tree, this two-class decision forest. So this two class is just telling us that, oh, we have a binary class, and for the multi-class, the settings is for a multi-class level. So I'm using this, and I can tune it by adjusting some parameters. So parameters like resampling method, the way it actually shovels the like the data, then the number of decision trees I want to use, the depth, the way I want it to split per node, the number of samples per level. I will leave it with the default settings. So I'll just connect this. So now I have my algorithm connected, and I have connected my data. So the next thing for me to do now is uh, try to evaluate the data, and also uh, score the data and evaluation. So that's what I'll be using this for. So score. So I have score model for that. So I'll be connecting this my split data to that, and also my train model to that. So I'm not it doesn't really have like any special tuning that I need to do on that. So I'm trying to. So the next thing is to evaluate my model, which I'm going to use this evaluate model item for. Okay. So I can now run. So basically, I have an end-to-end process for me to like train this Titanic data. So the next thing for me is to run the experiment, so I can see if I actually connected all these items correctly and check for performance. Okay, so the training is done now. So the next thing, since I am checking for the performance, so the next thing is for me to check this evaluate model to see the performance. Okay, so this so for classification problem, most times we use conversion matrix, recall, F1 score, precision, area under curve to check for performance. So checking for performance to check the number of correctly predicted values, and they are actually like 1, and the number of positive wrongly predicted values. So that's what this true positive is just telling us that, oh, this item is actually positive and it was predicted correctly. And this true negative is telling us that this item is actually negative and it was predicted correctly. So because we are dealing with zeros and ones, so for this false negative, it's telling us that it's negative, but it was predicted to be positive, and that's not correct. So I have 20 items that were predicted wrongly for the class 0, and I have 16 that were predicted wrongly for class 1. So that's just the explanation behind true positive, false positive, or false positive, true negative. And the accuracy is 0.98. The recall is 0.97. Precision. So these are the major, more like the important performance evaluation metrics for a classification problem. And I can see the graph too. So this is a ROC graph showing the relationship between the true positive and the false positive. So now the next step is since we have a trained model. So the next step is, okay, now I have a model. The question has always been, what do I do with this model? Should it end up on my laptop, or what's the essence of this training? So for most training, the essence is to solve a problem, and the essence of solving problems is just basically for users to be able to use it to solve their day-to-day encounter. So now I'll be taking us through how to publish a machine learning model as a web service, so that okay, other people can use it and be able to predict with what you've built. So this out. So there's a small icon at the lower part here. Set up web service. So now I'll be using this option, predictive web service. So this is more like the deployment part. Okay. So it's done. So this input is more like saying uh these are the expected parameters anytime, because anytime I want to predict a model, I need some features, more like, oh, I want to predict whether this person is eligible for loan. What are the features I'm trying to use to weigh whether this person is eligible or not? So that's what more like the web service input is, and the output is just what you're expecting, probably 1 or 0. So for this select column, I'll I have to remove survived, because survived is the column we are trying to predict. So now I have to bring this here, this input. Okay, so I have web. So I'll bring the input here and connect it to this core model and run again. Okay, so it's returning this error because I removed the survived column. So I'll try to check the reason why its name survived not found. So this is more like this experiment rated is more like my 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 trained model. Mm, okay. S- I think I added everything correctly. I don't know why this was okay. Let me run this now. Okay, so it's done. So, but the thing is, this select column shouldn't be part of what I'm testing. I mean, this survived column shouldn't be part of what I'm testing with. But I guess there is a mistake in my training experiment. But I'll go on to deploy the model as a web service. Because these select columns are the parameters that I'll be expecting in my web service. Like, oh, what are the features I really want to use to determine whether this person will survive or not. So okay, so it's live now. I can test. Also test in a preview mode. Okay, so this survived column is still there because I added it when because I added it here in my experiments. So I'll just go on and test the web service. So which so I can see that the columns are there already. Okay. Okay, the expectation is for this to be 100. So the score label is 1. So I don't expect this to be totally correct because I didn't really specify like the data type in my training. but I think we've gotten like the overview of the machine learning studio, how it works, and how one can build a model, test, and also it's possible to like deploy as a web service and also uh, as an API. So this is more like an end-to-end process to train a machine learning model on Azure Machine Learning Studio and also deploy as a web service. So I think it's better to try and practice this particular competition, these Titanic data sets on the studio, so that one can actually get a proper view feel of how the whole thing work, and also play around with different uh, experiment items, because they have like lots of experiment items to play around with. This is more like a base tutorial. So that will be all for this session.
Wow, this session was very awesome. Um, Basically, before I start this session, my idea about machine learning is I probably need to learn Python and be badass and code like that. And then the way you just analyzed the Titanic data set, I was like, damn, I don't need Python knowledge or our knowledge to work with this. And we were mapping and doing some wonderful stuffs. It's very awesome, very awesome. Thank you very much, Bushra. I believe we really enjoyed this session. Those on live on Teams and those on YouTube definitely enjoyed this session. And I would employ everyone also to just go and play around with Azure Machine Learning Studio. It's a fun environment, at least from what I can see. It's just draw line, and test, publish everything. That's doing here. Not literally like that though, but then um I'll just encourage everyone to just play around with it. Thank you very much, Bushra. And that will be all for with theory of beyond coding. So next week we'll be having some other amazing speakers. And next week we'll also be talking about something I feel is very important, which is getting into research. Next week we'll be having Vidant Bahel to talk about research and co like that. So make sure you all tune in and come back next week to listen to Beyond Coding Week 4. Thank you very much, everyone. Any question before um, we close this call? Mm, I don't think there's any question. But then, if there's anything you don't understand, you can always go back to watch the video. It's available on Teams, and ensure you, everybody on this call like this, ensure you join our channel and subscribe to our channel. Like this video. It's MSP Beyond Coding. Take care. See you next week. Bye.
All right, bye.